Okay, well, if you're on 4.6, it's Friday. One more day until the weekend. Just remember, you need to make sure you do the review and that you study for the test on Monday. You'll take the first version on Monday and the second version on Tuesday. And then I will be back Wednesday. Okay, so let's start with this cumulative practice. Cumulative practice says we're doing alternate interior and alternate exterior. And I don't know why, for some reason right now, none of my stuff is coming up fully. I think this happened with the last one. So if we look at the very first one, they're wanting us to classify these angles as alternate interior, alternate exterior, corresponding, all of that. And so they end up looking on your sheets of paper, they look like this. Okay, and they're wanting us to identify angle 4 and angle 5. Well, both of them are on the same side. Okay, and they're both interior angles. Remember, I talked about it being a hamburger, and this is the meat, and then here's the bun. Okay, so they are on the inside. So we would classify both of these as same side interior. Now, the second one's over here. We've got both are interior, so we know for a fact they're interior angles. Okay, and they're on alternating sides, so they are alternate interior angles. Okay, and we know same side interior angles are supplementary. So these are going to end up equaling 180 degrees, and these two are congruent, so they're going to be the same angle. Okay. Now, plot these points in the coordinate plane. Then determine whether A, B, and C, D are congruent. So you can plot all of them. You can go here. You can plot your points and then try to count. But again, I showed you something yesterday. Go into Desmos, and what I want you to do is you're wanting to compare A, B, and then C, D. So go into Desmos, and you're going to do distance. And you're going to do -3, 4, -3, 7. And it's going to spit out an answer right here for you. And that answer is actually 3. Okay? Then you can do the same thing, distance. +3, -4, 3, -1. Okay? And it's going to spit out the answer of 3 as well. Okay? Now the other way, if you did this a little quicker, I actually did this in my head. I noticed that both my x coordinates were the same on each one of these, so all I really needed to do was subtract my y coordinates. But if you can't remember how to do that, again, put it in Desmos. Both of these distances came out the same, so can I say that yes, AB, segment AB is congruent to segment CD, and that's exactly how you'd write it. Okay? And so then you're going to do the exact same thing with Desmos, but you're going to do it over here, and you're going to do distance of 7, -2, and then 2, -2. Okay? And then on the bottom, we're going to do the distance of 3, -4, 5, -4. Okay? And again, I'm doing this in my head because I'm recognizing that both my y coordinates are the same. You're going to end up getting that the answer to this is 5, but the answer to this one is 2. Okay? Okay, so we would say that AB is not congruent to CD. Okay, And again, that little Desmos thing is amazing. So now, okay, dilations are non-rigid motions. Everything else we did, a flip, a rotation, a slide, those were rigid. But dilations are non-rigid because, as you can see what I'm doing here with my iPad, I am increasing and decreasing the size, okay? Now, a similarity transformation, so here's a new one, is a composition of rigid motions and dilations, okay? Two geometric figures are similar only if there's a similarity transformation that maps one onto the other, okay? So congruence transformations, the original size, shape, everything is the same. But similarity transformations preserve angle measures only, okay? And what I mean by that is, if I take this page that I'm on now and I enlarge it, all of the proportions have stayed the same. Now, if I could take, let's see if I can do, if I did this triangle, and you can see if I go bigger or smaller, the proportions stayed the same. But if I somehow did it where the triangle ended up looking really skinny, so I just kind of shrunk it on the horizontal axis, or maybe I shrunk it on the vertical axis where it became really flat. I kind of like pushed it down from the top. Those are not similarity transformations. Similarity would be if I take this original triangle here and I'm either enlarging it, it still has the same angle measures, or I shrink it small, it still has the same angle measures, okay? So here we've got triangle, our example, ABC, and we've got the vertices of -4, 1, we got B and C, okay? And its image after the similarity transformations. So the first thing that you're going to do is we're going to reflect it. Our reflection is going to be on the x-axis. And then after that, we're going to do a dilation. And you can see here, we are doing a dilation. So our K is going to be equal to 2. And then that -1 means we're going to do a 180-degree rotation. Okay, we're going to rotate it 180 degrees. So let's look at it. Okay, here is our very first one. Here is ABC. Okay, and so first one was to reflect it over the x-axis. So I count up, there's 1 unit there, 1 unit here. Count up 3, so I count up 3. And same thing. So here is my second one. I've reflected it. Okay. Now, if you didn't have the graph, you could go back to where you know that rule, that if you're reflecting over the x-axis, that means we change the sign of the y. Now, once we reflected it over the x-axis, now we're going to come back here and we're going to do the dilation. Okay, so when we're doing the dilation, we've got this factor of -2, which means we're enlarging it. We're doubling its size and rotating it 180 degrees. That's what that means, okay? So all you have to do here now is take your x-coordinate and you multiply it by -2. X-coordinate, multiply by -2. And you do that for all the x's and all the y's. And now you're going to go and you're going to plot all of these new points that you calculated when you multiplied by -2, and you can see that we took this triangle, we rotated it 180 degrees, and we also enlarged it to 2 times its original size. Okay? Pretty cool. Yeah. Okay, now describing a similarity transformation. This is where sometimes it can get a little hard. Some of you are going to see it right away and others might struggle a little. Okay, and again, I might say it goes XYZ. You might say it goes ABC. So here they want us to describe a similarity transformation that's going to map trapezoid PQRS. So that means that this is my original one. onto this smaller one. So if I'm going from big to little, I instantly know I'm doing a reduction. So I'm going to have some K factor that's less than 1. Okay? Now, how do I know what the K factor is? So let's find out what K is. Okay, I'm going to count. It looks like side SR is corresponding to ZY. Now, one of the ways that I can do that is SR is my fourth and third number when I name the trapezoid. ZY is my fourth and then third number. So yes, those two sides are corresponding. My length of SR is 4. My length of ZY is 1. So when we reduce it, remember when we're making it smaller, the smaller number goes on top and the larger number goes on the bottom. So we have a K factor of 1/4. Okay? Now, does it look like that's my dilation? Now, how do I go from where it is to where it currently sits to where it ends up? Well, let's look over here. So you can see down here we've got our K factor. But what they're doing is if we rotate it 90 degrees, it's going to end up right here. And so we rotate it 90 degrees. Okay, it seems to be in the exact position we want where it's on the y-axis. So we rotate it 90 and then we're just going to move it down 3. Okay, so we're going to move it down 3. Okay, and so that's where we're going to get here. You can see they did our scale factor first. And then we're going to turn around and we're going to slide it down. Okay. Okay. Now, the other thing that they said is you could have done a 270-degree rotation with a scale factor of 1/4. That would work too. Okay. Now, here they want us, we're going to 1 now, graph triangle PQR with vertices at P, Q, and R and its image after, okay? So what you want to do is you want to rotate it 180 degrees about the origin. And remember, when we do this, the rule is x comma y will end up being negative x comma negative y, okay? So you just take each one of these coordinates, P, Q, and R, and you're going to change the sign of all of them. And so that's going to give you your 180-degree rotation. And then once you rotate it, to dilate it, take all of those new P, R, Q, and R coordinates, and you're going to multiply each one by 2. Okay? Now, 2 is wanting us to come over here and look at a similarity transformation that's going to map quadrilateral WXYZ, so the small one, to the big one. Okay? And so when I'm looking at, if you're trying to figure out what goes where, I'm like, point Z is last, D is last. So Z and D corresponds. So if both of those are on the inside, obviously I'm doing a flip. And they're both on the y-axis. So I'm doing a flip over the y-axis. So that means if I'm flipping over the y-axis, I need to do what? X comma y is going to end up being, flip over the y-axis means I negate the x-coordinate. So that's the first thing I'm going to do. Then if I look, okay, I want to look and see, all right, from D to C, let's count the slope. It went 1, 2, 3, and up 1. And then Z to Y, ooh, that one's a little bit harder. That's a whole lot harder to count. 1.5. It looks like we are doubling each one of those. So that is where you're going to go and you're going to get your K of a 2. Now, if you're unsure of whether you can double it, what I would do is you could put these coordinates in and use the distance formula. But let's be real. If we're looking at this example they gave us, we don't really have points sitting really nicely where we can determine what it is. okay? But if I go right here, this one right here, it looks like that is half a unit or 0.5, and it would correspond to AB, which is a full unit. So again, that kind of helps me know that we are enlarging it twice its size. Hey, that was a short lesson. Yes. So now you have 4.6. It's Friday. I want you to work on this. If you have any questions, you can hit me up on Remind. If I'm available, I will answer them. Make sure you are doing that Chapter 4 review so that you are very prepared for the test. Again, when you take the test on Monday, there won't be any retakes allowed. The sub will not have access to do that. But I will be a little more flexible time-wise for you to retake this test because of that. Okay? I will be in tutoring Wednesday morning, so you're welcome to come then. And I look forward to seeing you all then.